Okay, so I'm just it's dried out a bit. It's still very wet. I mean, this is just later in the day from a previous video. I had a very rugged charger which I've set up, and it's just literally you can see as a transformer, bridge rectifier and a capacitor. That's pretty much it. And obviously I can't leave this on charge. The original voltage of the battery before I started was approximately 14.5 volts. So I just put it in line, and now it's 49.7. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 cells. The reason why it's an odd number is because the lithium cells, when they're fully charged, they're around about sort of 4 volts. They vary between obviously 3.6 and 4.2, depends on the charge level, and the voltage is actually a very good reflection of the charge level. That's how a lot of times you actually measure the charge level, by the voltage. So, but this, because this originally was designed for lead acid and not lithium, then let me just put that a bit flatter. Ooh, there we go, that's better. It was designed for 6. In fact, I can show you them because I've still got them, or some of them. It was basically designed for these puppies. Yeah. Right, see the ones along the back? So I've got 5 of those there, and those are in reasonable condition. Originally it was 8, but 3 of them were completely dead, and so I just basically disposed of them. And then I've got 5 here, which are on a constant charge. It's a really low current charge. It's like a pathetically low charge, right? Because you don't really need much. It's just to maintain the voltage. And if I measured these, they're all about 8 volts now, because that's the output voltage. So what I've got there, you can see, this is a 6 volt transformer. It has two 6 volt turns, yeah. And when that's rectified, the output is somewhere around about sort of like the 8 volts from the and you can see there's obviously a little bridge rectifier there, and so that's basically maintaining the battery voltage is 8 volts. You know, it has sat here for best part of a year. You know, and obviously these aren't overheating. You know, you can check the temperature; they're cold, and or maybe lukewarm, and each of those has 2 taps on them, and they've got 2, as you can see, they've got 2 bridge rectifiers on them. I think I've got a video of this, and I've got 5 there, and I've got 3 transformers. So obviously one isn't connected, as you can see. These are 12 volt ones, which I've got a 12 volt charger there just sitting on it as well. Now, if you want to store a battery, this is the way to store it. Basically on a constant charge, on a maintenance charge, where the current is so low, it's like microamps, but it maintains the voltage of the battery. Now, these will stay like that. These are not brand new batteries, they're degraded, right? But these can stay like that pretty much indefinitely. You know, if you buy a battery and you leave it like this, 10 years later, it'll still be brand new. If you buy a battery and don't charge it, after 10 years, it will be a brick of lead, and there's nothing you can do about it because it self-discharges. All it's doing is it's basically compensating for the self-discharge. You know, and this is a 3 watt transformer. The battery is a 200 amp hour battery. So it's not going to overheat the battery. You know, I mean, 3 watts at 12 volts is a quarter of an amp, isn't it? That's the maximum power. Sorry, it's 6 volts, isn't it? So 3 watts at 6 volts is half an amp. This is a 200 amp hour battery, right? So the charge rate of a 200 amp hour battery, right? If you're going to charge it normally, it's normally about 10% of the charge. You charge it over sort of like, it's about 12-16 hours, and the charge current is a tenth of the capacity. So if it's 200 amp hour, it's 20 amps, right? That is the normal charge rate. This is putting in half an amp. So there's no way on God's green earth that's ever going to do anything to that battery. But it will maintain the voltage, which is the whole point. So those are the ones that came out. These are actually not the originals. The original were actually wets. They were Trojan wets. These ones are some Powerline AGM batteries, which I was testing out, and they did kind of work, but it kind of confused the charging system because these didn't have normally the charging system had a specific gravity meter to actually check the charge level, and you drilled a hole and you put it inside one of the batteries. Now I obviously can't drill holes in those and put them, and it wouldn't even have any. It's not got any fluid in it. Well, they have fluid, but it's absorbed, so you can't use it. You can't access it. Yeah, so it confused it, and it did work okay, but the inbuilt charger really didn't work properly with it because of the fact that it didn't have that specific gravity meter. So these guys are replacing those. These are obviously lithium cells, and the original voltage of the batteries varied between the maximum voltage was 8 volts, right? Fully charged, they had 8 volts on each one, and we had you had 8 in them, so that's 64 volts, right? So the maximum voltage would be 64 volts. Now, if these are 4 volts each, and you have 12 of them, that's 48 volts, right? If you charge them to the full, then it'd be 4.2 volts each, right? So that means it wouldn't be 48 volts, it'd be, what would it be, about 50? Somewhere around 50 volts, right? What I was going to do is I actually put 14 in there, which ended up with something like 60. It was about 65, 66 volts, I think, if I remember rightly. And it was like the controller wouldn't work because it was like the voltage is too high. And also the 8 volts is the actual voltage when it's charging. It's like the cutoff voltage when it's fully charged. And then when you remove the charger, right, the voltage then drops to about 7 volts, right, ish. Okay, and so then you've got 8 times 7, which is 56 volts. So it was looking for somewhere. I think that the cutoff voltage was actually something like 60 volts. That if the battery was over 60 volts, it wouldn't work because the voltage was too high. And these, when it had a full set, including the ones at the end, it was like 65 volts. So it didn't work because it was thinking there's something wrong. The battery's overcharged or something. You would think that the solution to that would be to actually drive the car and discharge the battery a bit. But it didn't work like that. So what I did basically is pulled out a couple of the cells. Well, I actually pulled out one, I think it was, because I wanted to put 14 in there. So I pulled out one, so now it's 13 cells. And, of course, the voltage of the 13 cells is around about the right voltage range. And you can see there it's 49.96, 50 volts. Isn't it? Now, I can't do it on the phone while I'm recording it, but I'm just trying to think if I can do it in my head. So the maximum voltage would be 4.2. Okay, so that would be 13 times 4, which is 13, 26, 51, I think, isn't it? Yeah, 52. It's 52, yeah? And then we've got to add all the 0.2 volts on them, so that's 13, that's 2.6, isn't it? Yeah. So that's 52 plus 2.6 is 54.6. Yeah, that's it. So the maximum voltage that should be showing is 54.6. That'll be when they're all fully charged. Now, that presumes that they're all charging at the same rate and they all have the same capacity. You know, they're charging from the same rate to the same rate. But they can be imbalanced, so you've got to be careful. So, you know, I won't let it charge that long. But it's just, I would probably let it charge up to about 50 volts and then leave it. You know, but these were actually obviously really reasonably well charged anyway. A discharge level is going to be about 3.6, I think. If it's below 3.6 volts, then you're talking about it's low on charge. I think it tends to plateau at about 3.6, 3.7 for like between 80% and 20%. And then when it gets below 20%, the voltage starts dropping off again. So, you know, 3.6 times the 13 is 144 times 12. 144. Oh, I don't know. I can't work it out. Yeah. But basically, it'll still be enough to push the car. But, of course, it's only a small pack. So it's not going to go very far, is it? The capacity of these, assuming that they're like brand new capacity, which I don't think they are, but I think these are 30 amp hour. I think they're 30 amp hour each. Okay. So that's, and obviously because we've got the whole string, that's 30 amp hour. So we're talking 30 amp hour at 50 volts-ish, aren't we? That's 150 amp hour. 150 watt hour. Yeah. Which means it's not going to go very far, because the original capacity was, I believe it was 10 kilowatt hour. Is that right? 150? No, it can't be right. 1.5, I would say. 1.5 kilowatt hour. Yes. Yeah, and the original range was somewhere, a practical range was about 40 miles, and that was with a 10 kilowatt hour battery. So we're talking about, yeah, you're probably talking about like 4 or 5 miles on that. Which is, I believe, my house, which is also up a hill, from here is about 5 miles. So it might just make it, but it's going to encounter a hill, so I doubt it. So, but I have more. I can put 2 in. Which means it'll get home. Yeah. And I'm doing the capacity from memory as well. Anywho. Yeah, so we're actually finally on the mend, which is good. There's some serious electrical problems. I'm going to have to pull all this out, because I think water's got into the wiring, essentially. So all of that's screwed. And then also, you can see this has been cleaned out once, but you'll be able to see stuff growing, which is probably part of the problem. The main problem is down there, and you can see obviously